Hello. In this video, I would like to share with you ways to transform the graphs of quadratic functions. First off, it's important to note that parent functions are the simplest form of a family of functions. In other words, a parent function can be modified or transformed in shape to meet the needs of a particular set of conditions. For quadratic functions in standard form, the parent form that preserves the general shape of the graph is f of x equals x squared. We use the complete the square method to establish the vertex form of a quadratic that is written in standard form. The vertex form is the best way to identify transformations of the parent graph into its new form. The following steps outline the general process for rewriting a quadratic function into standard form, but we may not have to utilize each step. Step 1 is to isolate c by grouping the first two terms of the quadratic in standard form. Then, we identify the greatest common factor in this group in order to reduce the a value to equal 1. In step 3, we utilize a mini-formula to complete the square trinomial. We will add half of b squared inside the grouping symbol. Since we are systematically selecting a value to add inside the parentheses, in step 4 we must modify the outside of the parentheses to keep the equation balanced. Be careful at this step, since the number you modify on the outside might not be the same as the number on the inside. We'll see this happen in example 2 below. Finally, in step 5, we rewrite the quadratic in vertex form by factoring the square trinomial just created. Here are two examples. In number 1, we could easily isolate c. And after that, we would skip step 2 since the a value is already equal to 1. I'll rewrite the function now with a little more space in the grouping symbols to make room for step 3. Our b value is -4, and half of that is -2, which squared is 4. This will be the number we use to complete our square trinomial. Immediately, I will subtract 4 on the outside so that our net result is 0 and the equation remains balanced. Finally, factor the square trinomial, combine like terms on the outside, and observe the vertex form of the quadratic function. In example 2, after grouping the first two terms, we should factor -2 from the first two terms. And after completing the square, we should add 18 to the outside of the grouping symbol. We do this because of the 9 that was written inside, which is affected by the -2 distributing from the outside. -2 times 9 is -18, and to offset that, we add 18 on the outside. And after factoring, we are left with a function written in vertex form. When graphing a quadratic function in vertex form, we must first consider what we call the parent function, f of x equals x squared. When x is equal to -2, f of x equals 4. So we have the coordinate to plot, -2, 4. Similarly, when x equals -1, f of x equals 1, and we have the coordinate -1, 1. The remaining points follow similarly. These 5 points are often called key coordinates, and we can transform their locations to graph any quadratic function written in vertex form. We call the shape of this function a parabola. You should notice that the vertex form of a quadratic has 3 numbers that are used to transform the parent function. The numbers are in the position a, h, and k. The a value, which is the same as the a value in standard form, identifies the vertical stretch or compression of the parabola. It also determines whether the parabola opens upward or downward. If a is positive, the graph opens up, and if a is negative, the graph opens down. When the absolute value of a is greater than 1, the parent graph stretches taller, and it does so by a factor of a. And if the absolute value of a is between 0 and 1, the graph will compress shorter. The values of h and k determine the x and y coordinate of the vertex, which is the top or bottom of the parabola. Notice that in this form, the opposite of h is indicated in the function, so we will use the opposite of this number when identifying the vertex. In example 1, we should note that the vertex of the parabola is located at 2, 3. And with an a value of 1, the parabola is the same shape as the parent graph and opens up. In example 2, we should note that the vertex of the parabola is located at 3, -1, and with an a value of -2, the graph is 2 times as tall as our parent function and opens down. I hope this video helps you to graph your quadratic functions. Good luck!